Honest marks for maths and history were given, as well as the main standard deviation of the marks of each subject. Find honest set score for each subject. Well, set score is x, take away the mean, divided by what? I remember? Divided by sigma, yeah. Okay, which is going to be 80 take away 75. 80 take away 75 divided by 12. All right, what set score is that then, guys? What is it? 5 over 12 in decimal form? I know we usually give it in, yeah, you're right, 0.417 or 5 over 12, okay? Now, her set score in the other subject was, she was below average, so 70 take away 78 divided by 10, which is minus 8 over 10, which is minus 0.8. Done. In which subject did she perform best? Well, she actually performed better in, when you're above the average, that means you perform better. So she definitely performed better in maths. Reason being is her set score is above the average as opposed to a set score below the average. And his friend Kira got a set score of 0.5 in history. What raw score did Kira get? Well, Z equals X minus mu all over standard deviation. A set score of 0.5 equals X. And what's the average for our history? 78. Did you think she gets above 68 or below 68? Oh, sorry, above 78 or below 78? How do you know it's above? It's a half a standard deviation added on, isn't it? So it's 10 multiplied by 0.5, which is 5, plus 78, because it goes over the other side. So X equals 83. We kill with that. This is 14 and 8. Okay. To test tennis balls, they are dropped from a given height, and the height they rebound is measured. Balls that rebound less than 128 are discarded. Assuming that the rebound height can be modeled with a normal distribution with mean of 134 and a standard deviation of 3, work out how many tennis balls in a batch of 1,000 will be rejected. So look at this. Let's go and draw my standard curve, okay? Dead center, which is meant to be the top of the mountain. I'll just adjust my graph here slightly. Everybody see it now? It's the top of the mountain now, okay? So what's the average? The average is what, guys? 134. Now, 128 is over here somewhere. That's 128. What's the gap? The gap is 6. 6 is actually 2 standard deviations. So the gap is 2 sigma. And what we read up earlier is that a gap of 2 sigma will have a 47.5% chance, yeah? Now, what does that mean about this region here? The region that's under 128? 2.5%. And what's 2.5% of 1,000? Yeah. We all good? As part of our geography field trip, Alice is measuring and comparing the lengths of pebbles on 2 beaches. On the first beach, the mean length is 8. So mu is equal to 8. And standard deviation is 1.4. Sigma is 1.4. On the second beach, the mean length is 9. And there's a standard deviation of 0.8. Okay. She found a pebble that's 10 millimeters on each beach. She claims that this is less likely to happen on the first beach. Use standardized test scores to test her claim. The bigger your set score, the less likely it is to happen. Now, what I mean by that is a really small set score is really unlikely, and a really big set score is equally as unlikely. It's how far away from 0 you are. Does everyone understand that? Set score that's further away from 0 is less likely to happen. So the closer you are to 0, the more likely you are to happen. All right. So here we go. Let's use standardized scores here. Right. Z equals x take away mu divided by sigma. So what do we have here? What's x, lads? 10 take away 8 divided by 0.4. What's 2 divided by 1.4? 1.43. Set score of 1.43, okay? Now next one. The set score is x, 10 take away 9 divided by 0.8, which is 1 divided by 0.8, which is 1.25. Now, because this one has a larger set score, it's rarer because it's further along the standard normal curve, which means it's a shorter line. Okay?